Section 2.2, the slope of a non-vertical line. So suppose I have a line in the plane. So let's just draw some line in the plane. And let's do this relative to some coordinate system. Let's say, and suppose that this is that it is not parallel to the y-axis. Then let me take a point on the line, go 1 unit in the to the right, and then m units in the y direction, either up or down, so that I land on another point on the line. Let me define the slope of the line as being this number m. If I have to go up, then I will make the sign of m positive. If I have to go down, then I'll make the sign of m negative. By similar triangles, I have that is well defined. It's uniquely defined as being the same for any starting point on the line. So let me give you some notation. Suppose that m is, well, suppose that I take the vertical change, this distance here, over the horizontal change, this distance here. Then I will call that the slope of my line, or the change in y over the change in x. That will be the slope of my line. And I'll just note the slope of my line by the letter m, the change in y over the change in x, delta y over delta x, the rise over the run. For each of these, I'm assuming that my denominator is not 0. So I can do that so long as this is a non-vertical line. Note that the slope of a vertical line is undefined, whereas the slope of a horizontal line is 0. Sometimes we say that the slope of a vertical line is infinite. Suppose I take 2 points on the line, x0, x1, y1, and x2, y2. And suppose that x1 is not equal to x2. Then the slope of my line is just y2 minus y1 over x2 minus x1. Two lines in the plane will be said to be parallel if they never intersect, or if they're coincident. Please note that some people consider that two coincident lines don't have the same slope, but it'll be easier, so I give the condition here to consider coincident lines to be parallel. So suppose I have two lines in the plane such that neither line intersects. And suppose that I do this relative to some coordinate system. And suppose that neither of these lines are vertical. Then both of these lines have slopes, say m1 and m2. Say the slope of line L1 is m1, the slope of line L2 is m2. Then two lines, L1 and L2, would be parallel. We'll denote the fact that they're parallel by these two parallel lines. If and only if their slopes are equal. Perpendicular lines. So suppose I have two lines in the plane. Two lines in the plane will be considered to be perpendicular if they intersect at one point, and at this point of intersection, they intersect at a right angle. Suppose that we draw these two lines relative to some coordinate system, that neither L1 nor L2 is vertical nor horizontal. Then both M1 and L1 and L2 would have slopes, and so let M1 be the slope of L1 and M2 be the slope of L2. Then two lines, L1 and L2, are perpendicular. I'll denote perpendicular by this symbol here. If and only if the product of their slopes is -1. In this case, if one of the slope is undefined, then I'll have to have that the other slope is 0. If and only if, and this is an easier way to sort of state that, if M2, the slope of one line, is equal to the negative reciprocal of the slope of the other line. So in this case, if a slope of one line is 0, I will say that a -1/0 is infinity. And if the slope of a line is infinity, I'll say that -1/infinity is 0. And so this will now work for any line. So two lines are perpendicular if and only if the slope of one line is equal to the negative reciprocal of the slope of the other line. So let's do some examples. Let's say on page 214, let me do problem number 17. Find the slope of the line passing through each pair of points if possible. So I have 2 points. Maybe I'll call this x1, y1. And this point x2, y2. Then the slope of a line from what we said earlier is just equal to the change in y over the change in x, rise over run, delta y over delta x, y2 minus y1 over x2 minus x1. And so this is equal to y2, 1, minus y1, -7, over x2, 4, minus x1, 8. And so I have 1 plus 7 is 8, divided by -4. And so this is equal to -2. So the slope of my line through these 2 points is -2. Let me do problem number 23. So let's find the slope of these lines. The slope of the line through these 2 points. So let me call this, let's say x1, y1. And let's call this x2, y2. So again, the slope of a line through x1, y1 and x2, y2 is y2 minus y1 over x2 minus x1. Assuming, of course, x1 is not equal to x2. Oh, okay. And so if C is not equal to A, then x1 will not equal x2. So that's what this condition means. So let's find the slope. So this is equal to y2 minus y1 over x2 minus x1. And so I have a minus c divided by, get rid of the parentheses, and so this is just b plus c minus a minus b. The b's cancel, and so I get a minus c over c minus a. Again, c is not equal to a, so I'm not dividing by 0. Let me get just a little bit more room here. And so a minus c is the same as c minus a. The only difference is the order, since there's and these both have negatives in the middle. So therefore, I can cancel. When I cancel the numerator, I'll put a minus. So remember that if these are the same, and the signs are the same, then when I cancel, I will keep the sign of the numerator as being whatever sign is the mutual sign. And so -1 divided by 1 is -1. So therefore, the slope of the line through these two given points is just -1. Let me do problem number 44. Determine whether the lines with the given slopes are parallel, perpendicular, or neither. Well, M1 is not equal to M2, so it's not parallel. M2 is not equal to this way. M1 times M2 is not equal to -1. Positive times positive is not negative. So these are not perpendicular. So since they're neither parallel nor perpendicular, then, well, the answer is that they're neither parallel nor perpendicular. Let me do problem number 67. So I want to determine which, if any, of the three lines PQ, PR, QR are perpendicular. So let's look at the slope of the line PQ. And so let's do the change in Y over the change in X. So this is the slope of the line PQ. So I'll do PQ, -5 minus 4 over 2 minus 5. So I get the slope of the line through PQ is -9 divided by -3, which is a +3. Okay. Let's look at PR. And so P is the point 5, 4. Q is the point 2, -5. So let's do Y2 minus Y1 over x2 minus x1. So y2, let's say, so this is PR. And so P is 5, 4. R is 8, negative 3. And so I get negative 3 minus 4 over 8 minus 5. And so I get the slope of PR negative 7 over 3. So that's the slope of the line through the point PR. And lastly, let's find the slope of the line through QR. And so Q is 2, negative 5. R is 8, negative 3. So again, we'll do y2 minus y1 over x2 minus x1. So the slope of the line through Q and R is negative 3 minus a negative 5 over 8 minus 2. And so that is Q and R. And so my slope through the points of the line through the points Q and R is negative 3 plus 5, which is a positive 2, over 8 minus 2, which is 6. So I can reduce this. So the slope is 1/3. So, oops. Let me say that the slope through the point wait 1 second. The slope through the points P and Q was equal to 1 second, I forgot what it was. PQ, and I got P and R. So P and Q was 3. So through P and Q was 3. Sorry, I'm still trying to get control back. All I was doing is moving an inch up. So 3. So P and Q is 3. So 3. The slope of the line through Q and R? No, P and R, PR. The slope of the line through P and R was negative 7/3. And the slope of the line through is 1/3. Well, no line is perpendicular because so I have that none of the products the products of two of these three numbers is -1. And so if I look here, well, certainly 3 times -7/3, that's not equal to -1. And good. And 3 times 1/3, that's 1, not -1. -7/3 times 1/3 is not -1. So that means that none of these are perpendicular. Okay. Okay, I was able to move that. Let's see if I can draw. Okay, so none of these are perpendicular. And that's your answer.